Hi, my name is Adam Bean, and today I would like to discuss with you why or show you why I consider Java EE as very lightweight, effective, and productive platform. I'm working as developer consultant, and I focus on development. And sometimes I'm writing books and articles, and sometimes it means if I'm on the road or in my dead time and leisure, I'm writing articles and books. And occasionally I also speak at conferences. I really enjoy, for instance, the Java One conference. And about three times a year, I'm delivering workshops or organizing workshops at Munich's airport. So lots of fun. So we are coding together 3 days Java 6 applications and discussing best practices and patterns. What's funny, in recent years, I actually deleted more code than I've written. Why that? What I see in my enterprise daily work is there is a lots of exaggerations, indirections, data access objects, data transfer objects, and no one actually knows why they are there. This is actually the sad part of the story. So there is a lots of plumbing without actually knowing why it's there. And the reasons are, of course, there are, of course, historical reasons. So starting with J2E, J2E required lots of plumbing. And now we have more modern platforms like Java 5 and Java 6, but the plumbing just remained. But what's sad, though, is that this plumbing is still considered as BA best practice. So, and what I try to do is just to remove all the plumbing and concentrate and focus on business logic. And it is actually not a big deal to write overcomplicated and exaggerated applications. It is a lot harder to write business-driven applications with a minimal amount of infrastructure. But what's interesting, Java 6 is perfect capable for that. So with Java 6, you can just concentrate on the business logic and enhance the business logic or inject the infrastructure later. Okay, this is one of the recent books is talks about rethinking the best practices, and this book talks about a small application I've written for my weblog called X-Ray, and then it's this real-time statistics software written with Java 6, Maven 3, and REST services. So, what are, in my opinion, the core feature of Java 6? The conceptual feature, convention over configuration, in my opinion, is the biggest. What it actually means is you don't have to configure anything. You can just concentrate on the business logic and just write business code, and Java 6 will provide you with suitable defaults. What suitable means is, for instance, if you are building a JSF application, you don't have to provide faces config XML. For page flow, you can just return in an action method, or you can return an action name in the method. And if the action name matches with a JSF view, this view will be just the used as the next page without any further configuration. This wasn't possible before Java 6. Or in JPA case, if you have an entity with a persistent entity with attributes, and all the attributes are persistent, you don't have to configure that. What you have to configure is the exception from the rule. For instance, if you had a transient attribute, you would have to declare that as transient. And finally, dependency injection. So what, dependency injection is in CDI case. What it actually means is if there is only one possibility, you can just inject the possibility with at inject without if it is not ambiguous, you won't have to provide any additional configuration. If it were ambiguous, you would have to configure that. And finally, EJBs. If you deploy an EJB, it is transactional and monitorable and secure and thread safe per default. You don't have to configure anything. So I really enjoy that, because before Java 6 and Java 5, we had to write a lot of XML, and the XML was just dump XML because all the information was already in source code, and we had to repeat that in in XML. So what we used back then was Xdoclet. It was small enhancement of so actually Javadoc doclet, and Xdoclet generated all the plumbing for us. So it was obvious back then in J2EE 1.4 that the whole XML configuration is actually superfluous if it can be generated. So dependency injection was introduced with Java 5. So, but it was very, very simple. So you could just inject with ejb, and you could only inject ejbs. It was sufficient for most applications, but you couldn't build, for instance, application server based on ejb dependency injection. This was changed in Java 6. So in addition to simplistic ejb dependency injection, inject was introduced, and what inject means is you can inject external components with inject POJOs, and it is extremely powerful model. Actually, I think there are no more limits. You can inject whatever you want, whenever you want, and there are even pluggable extensions. And the CDI dependency injection is also based on conventions. As I already said, is if you have just one dependency, you can just inject it without any configuration. And by the way, the usual configuration of CDI happens in source code with annotations and not with XML. Dry, don't repeat yourself, and die, the application is evil, is also an interesting concept. What it means, Java 6 allows you to write the metadata in one place. For instance, if you have JPA entity and you annotate the fields with bin validations, JSR 303, it will be validated twice and probably 3 times in Java 7. So in Java 6 it will be validated for JSF and be also validated for JPA. And in Java 7 you could even reuse that for RESTful web services. And keep it simple and stupid. It's also funny concept. By the way, dry and kiss and Yagni, you aren't gonna need it, are actually general terms and have nothing to do with Java, but can be perfectly applied to Java EE. So what KISS means is with Java 6 you can write actually applications that are lots easier than Java's E, so you can keep them very, very, very simple. So, and what becomes more and more important because of movements like DevOps or continuous deployment is the enterprise readiness. What I understand under this term is, if you deploy a Java 6 application, it will be monitored by the application server per default. So there is no more reasons to provide additional tools, monitoring tools, whatever. You will get at least statistics about threading, transactions progress, queue depth, errors. Every application server will provide you with these statistics. And this is a huge difference to web containers. So applications, out-of-the-box applications deployed on web containers like Jetty or Tomcat are nothing else than a blind flight. So so what you only will see usually without any custom code is the behavior of the servlet, what is basically nothing, because the servlet is just usually the controller of a view framework, and you can configure it entirely or not at all, and you will only see the statistics for methods to get in the post, which are actually global. So on the enterprise readiness, I also understand somehow well-defined deployment. It means in the case of Glassfish, you could deploy your applications with putting your war or EA to a folder, or using even REST to upload your application, or the admin console. So enterprise readiness means the application servers are usually already well integrated with tools delivered by operations, and you can easily monitor them and deploy them and scale or manage the application servers. So productivity. Unusual story. What I really like is jcp.org, Java Community Process, because the whole Java EE documentation is free and waits for download. And this is actually what I do in my projects. So what I usually do, I have here I download. I go to my folder just to show you, and these are all JSF specifications, that these are all PDF specifications I'm using in or Java 6 specifications, and I don't read them completely, of course, but they are perfect just to find answers for your questions. For instance, if you are interested in a connector implementations, here is it. 3 implementations about connectors. And if you are interested, for instance, in connection management, you will find the answer inside the PDF. So you see everything connection related and state diagrams, how a JCA connector manages connections. And the same is true, for instance, we already talked about persistence JPA. You will find a lot of examples. For instance, here, select statement, JPA, QL, whatever you need, and everything is for free. So what I use in case I need some more information, I just search this topic for search this folder for terms, and you can download everything from JCP for free. So if you go to jcp.org, and for instance use 316 is the Java 6 specifications, the number of the Java JSR, Java specification request, Java 6, and you can just download from here the PDF file. And or 317 should be, I think, EJB or JPA or something. Yes, it's persistence, JPA persistence, and 318 should be EJBs. And 303 is the bin validation. And this is actually unique. Why? Because I'm not aware of any other platform which comes so well documented out of the box. And this is not only specifications, readable specifications, also Java 6 tutorial, which comes for free as PDF. And what you also see here is there are lots of individuals and companies working together on such a JSR, Java specification requests. And why is this good? Yes, because of the broad support. Right now, Java 6 supported by about 14 different application servers, which is actually a huge success. So all major application servers are already supporting Java 6. And why is this good for us as developers? You only have to read this specification or to learn it once, and you are able to deploy your application on multiple application servers. This is actually what I enjoy. The truth is defined in one place in jcp.org, and it is of course reused by book authors, but you don't have to buy books. It's just enough to start to download the specifications. And there is also great Java EE tutorial, also free. So you can download the tutorial or browse through the tutorial or download the PDF book. So what I also enjoy is the setup. So if you are starting with, let's say, Maven, so let's do it. Then I just start Maven, archetype generate. There's a wizard, and I just have to find a Java 6 project. Type, it is around 380 or something. It is here. 387 is the number, web app Java 6. So 387. And group ID is com Java E, or better is of course org Java E. Artifact is rocks. Version is okay. Package perfect. Yes. And what it did, it created for me a project with the name rocks. So now I would like just to show you the structure of the projects, and would start a NetBeans, a free IDE, which is extremely capable of implementing and developing Java EE projects. I would just go to the junk folder. This is what I use for demos. So it's there. And now I can just start it just running it. So this will already work. But more interesting is the single dependency. So if I look at the dependencies, there is only one external dependency required, is the Java EE Web API with the version 6.0. What it means, you only need one single jar to compile all the Java 6 application, which is actually quite interesting. Yeah. Okay. So, declaring versus implementing is also interesting. It is actually a really interesting topic about Java EE and complexity in general. What I see in my projects is developers attempt to start with nothing, with a plain web container, with the excuse it is more simpler than Java 6, and then end up implementing transactions and threading with overcomplicated thread locals and singleton solutions. In Java 6 case, you would only have to apply a single annotation at transaction attribute, and with this annotations, the Java 6 application server will manage the transactions for you. So the question is, would you like rather to implement everything from scratch, and at the end of the day you will end up with a simplistic application server, or just use the application server for that? And in my opinion, the complexity comes not from Java EE. The complexity comes from the nature of Java EE. Everything is so complicated because we have to deal with distribution, cache synchronization, locking, consistency, availability, and all that stuff. And this is complex, not Java EE. And of course, it's a lot easier starting with a simple servlet and implementing everything on the go, but you will end up with hard to maintainable application because you will have to maintain the infrastructural code you build plus your domain logic. What I also enjoy in Java 6 is a clear separation between platform and domain code. So there is actually no dependency between a business code and Java EE code. For instance, if you would like to deploy an EJB, you'd only have to apply a single annotations at stateless on the class, and this is enough to have an EJB. There is no need to implement an interface and inherit from an abstract class. So lightweight. What's really funny is actually in several projects, what I see is a funny phenomenon is architects are selling an architecture as lightweight, and they have Tomcats or Jetties in production. And what turns out is that the application archive is orders of magnitude bigger than the whole server installation. So it is not uncommon to have 20 megs server installations and 500 megs wars or ears which have to be deployed to the servers, usually wars in the case of web containers. In my case, this is not lightweight. I have no problem deploying bigger servers, and then could be even 500 megs or even 1 gigabyte, which is not the case. For instance, Glassfish is around 200 megs, and JBoss and the others comes with similar size. Probably some commercial applications are more heavyweight, but the vast majority of open source application servers come with extremely small footprint. And what, in my opinion, lightweight means that you are deploying extremely small wars to a bigger servers. Why? Because I'm really interested in short turnaround cycles. A small war can be zipped and packaged very fast, and in a bigger war takes longer, and this is just waste of time. So I'm interested in smaller wars and bigger servers. I have no problem with a bigger server because hard disk is extremely cheap, and even the difference in the RAM footprint between application servers and web containers is negligible. So I don't know, Tomcat probably will use about 5 megs RAM, and Glassfish or JBoss or Tommy will need about I would say 20 to 60 megs of RAM. So small deployables very important in my case, fast deployments. Deployment should take seconds and not minutes or hours. And what I really enjoy is you don't need any external dependencies. And as I said during my introduction, I'm working with Java since 1995. And what caused trouble were forgotten external dependencies. It is not uncommon to use an external dependency, an open source one, which is no more supported. And this dependency over time becomes harder and harder to manage, and you cannot fix them because there is no more, it is no more maintained by the community. So what we had to do once is we had to decompile the external dependency, fix the problem, recompile that, and document the process so that these external dependencies wouldn't be accidentally replaced by another Maven deployment. So external dependencies cost some amount of work. And what you should do for long-living projects is, if you really would like to rely on external dependencies, just to download the whole source code, make it buildable, and in case something go wrong in the future, you can just build your own or maintain your own source tree. This is the cost of external dependencies. So what I do in my projects, in Java 6 projects, I actually forbid to use any external dependency. And if someone would like to have something, have just to justify that by writing just a very short explanation why this external dependency solves a particular problem. If the reasons are hard to explain, it is probably not worth to use that. So try to minimize external dependencies. Usually everything you need is already on the Java 6 server. So conceptual scalability. What I mean by that, so you don't need XML at start. You probably only need a view annotations, and only view, I would say you need add stateless for transactions, add inject for inject another layer, add persistence context to inject entity manager, and one add entity to declare a class as persistent, and add ID to declare a persistent ID. And you can build with that any CRUD application you like, create, read, update, delete. There is no bloat. You only need these dependencies without any additional work. The learning curve is really flat. So actually what I see right now is people are using Java 6 without knowing that is actually Java 6. In some projects, developer build domain logic without knowing that they actually enhancing EJB or CDI managed beans. So it is a very good idea to start with only a view annotations and learn on the go. I wouldn't start with extensive trainings and courses. I would just think about a small applications, what's fun or halfway usable, and try to implement this application with as less amount of Java 6 as only possible, and is as less lines of code as only possible. So try to concentrate on the business logic and use Java 6 on demand. A few lines of code say more than 1,000 slides. So this is actually the reason why I would like to show you Java EE from the code perspective, and would like to start with a small application. And the question is what we should build, and I would start with Java 1 favorites. So it would be a small application which cares about your favorite sessions. So Java EE web application, and this is actually new in Java 6. So you can deploy whole application as wars. There is no need to introduce ears. Wars are faster and simpler. So Java 1 favorites. Enable context and dependency injection will generate a very small XML deployment descriptor, a very short one, and it is extremely short because it actually consists of one tag. But this, guys, is important. Without beans XML, you won't have add inject dependency injection. So I would just create a project and then try to run it. So Java 1 favorites, run. This will create the war and deploy the application, and it's deployed. So then I would like to create a JSF page because it is the easiest way to start with, and usually you would like to have something which is testable, and I usually start either with JSF or with RESTful Web Services. So Java 1 favorites. Welcome. So as you see, the JSF is deployed. So what you would need is I would try to build a more realistic Java 6 application. So what I would like to introduce as a backing bean with the name index, and the backing bean will care about the state of the JSF page. Package is arc.java1 favorites. So, and there's a annotation called model, and what model does is it makes the index visible for JSF, and this index will be created and destroyed for each request. So this request scope named, actually, you can see that this is named on the request scope. The request scope means this manage bean only survives one request, and named means it is visible to JSF, and the default is the simple name of the class. So get greetings, and just to show you how it works, welcome Duke. And now you should be able to use this in the page. And as you see, welcome Duke works perfectly. So this was the index. So if I click here, you see this is the reason why I was able to refer to the backing bean is the name of the class with first lowercase character. So, and greetings invokes a method get greetings. But what I would like to create is a class called technical session, TS. There are actually no esoteric sessions in Java 1, but the official name is technical session with, I think, name. There's a name and ID. And the ID is like TS something. And I will just create a constructor and also a toString method. Forgot one. The toString method, yes, both. It's better now. Okay, so what I did, I create a technical session class with some attributes. Getters and setters are needed for data binding. What I would like to do is to populate the data or to bind the data from the JSF to the class, so move the data from the JSF to the class automatically. And for this purpose, I will have to enhance the index with private technical session. And to show you the lifecycle, I'll create a lifecycle callback on init, and with post construct, and I will create technical session here, and would like to expose this as a method. Get session. So now you see there's an error, and what I would like to do is I would like to create a form. And so 2 text fields, and the first one will bind the session and ID. And the other one, the name. This would be the ID and the name. No, name. And what we also need is very simple. I could use some UI containers, but for our purposes, just to show you the capabilities of Java 6 should be just enough. And a command button, and I would like to bind the button to the backing bean. Action, and the action is index add. So I have to create a method. First, I'm in the index, and in the method add, object add. I would like to add that. So probably just give it to system out plus this session return null. So saving, and just you see ID is TS42, and Duke Rocks would be your favorite. And what you see is technical session ID TS42 Duke Rocks. So what we have already is we are able to pass pre-populated domain object between the JSF page and the backing bean. We would like, of course, to store the technical session to a database. For this reason, the most simplest thing you can do is to create a session store EJB, and the session store EJB is a stateless session bean, and what we also need is to use JPA, and for this reason I would create here the entity, and this guy needs to be a primary key. So now you see here we have a problem, and the problem is we don't have any persistence unit. So what persistence unit is, it is very small XML deployment descriptor, or small. It's a deployment descriptor which defines in which database this entity is going to be stored. So I will just create it, and you see this is Eclipse link, and sample is the sample database, and drop and create means that the database is recreated, or the schema is recreated on each deployment. And the persistence unit doesn't actually matter, because we have only one. If you have only one persistence unit, then the convention is it can be just injected without actually knowing the name. So now it's created, and in the session store I'm able to inject the entity manager with persistence context. And I don't have to specify the name because there is only one. And I need a method save technical session TS EM merge or persist. So what it means is the session is either persisted or either inserted or updated in the database. So this is the EJB is ready to go, and it's stateless means the transaction is getting to be started here and committed at this point. So let's try it again. So what we have, ID is TS42 and Duke Rocks was the ID, and seems to work. So let's look at the database. it was technical sessions, technical session. And there is no Duke. Why not? Because I forgot to inject the EJB to our backing bean. So let's do that. Session store, add inject. And here I would like to persist. Not session, sorry, session store. To save the session. So what we did right now, we injected the session store into the method add and into the index, and we are able to use the EJB from a backing bean. And so let's retry that. I will just restart from the beginning. TS21 Rocking Duke. And looks still okay. And as you see, Rocking Duke is there. So I'm also able to introduce a new Duke. Tag Duke. And the tag Duke should be here. So as the whole life cycle from the flow of events from JSF to backing bean to EJB31 and JPA seems to work. The most interesting part is here. The persistence context is injected, and by the way, the entity manager is configured in a persistence XML. And the only dependency on Glassfish right now, this is the application server I'm using, is this line of code. What it means is I'm relying on Eclipse Link, but if I'm deleting that, it would mean just take what is deployed on the application server. You also see here the bins XML, which is basically empty. There's a single tag. And yeah, the technical session is the entity, and it is used by JPA and JSF for data binding, and index is the backing bean. So with 3 components, you are able to build your own CRUD implementations. And what you can also do, what is also well integrated, is bin validations. For instance, I could say the name of the session shouldn't be the size, should be between 2 characters and let's say 10. So right now, let's try. Could say TS size must be between 2 and 10. As you can see, I can use bin validations from JSR 303 and apply them on entity. This is what I meant by dry. Don't repeat yourself. And this this metadata is used for validation twice. The first time in JSF and the second time in JPA. If I would somehow manage to hack JSF, I still wouldn't be able to save the technical session in the database. What also interesting here is the annotation at inject. So if we look at that, it comes from javax.inject. And this annotation here is defined by a specification called dependency injection for Java, and it comes, this is 330. As you can see, it was defined by Rod Johnson from SpringSource, is the Spring creator. And Bob Lee, at that time, he was at Google and was lead of the project called Juice and many other companies. And what's interesting with the specification, it was actually introduced afterwards. Java 6 was almost ready to go, and Rod Johnson proposed this specification. And what happened then is Java 6 was refactored to adopt the specification, this add inject and add named. We saw add named already. So right now we have inside Java 6 the same binary, the same annotations as Spring has in Spring 3 and plus plus, I would say. So what also means is it is actually doesn't make any sense anymore to combine Java 6 and Spring for dependency injection reasons. It is technically possible, but it will be in longer term harder to maintain, because no developer will be able to say, just looking at the code, whether Spring or Java 6 are in charge of injecting the particular component annotated with add inject. So add inject is the annotation which came from Spring, is also core part of Java 6. In Java 6 you can use add inject to inject everything, and just using Spring in Java 6 wouldn't make any sense, because then you would have two service provider implementations for dependency injection. I'm just talking about the core dependency injection. This is interesting. What also interesting is our transactions. So transactions are necessary. So I can show you here with just disabling stateless. What happened right now, the session store is no more an EJB, it is a CDI managed bean. And as a CDI managed bean is not able to start transactions, so we will retry our attempt to store the session, TS and 21. And you see transaction required exception. We are not able to store the entity because it, we are not starting the application. We are not accessing the entity manager within a transaction. So it's required. Just re-attempting this. Now it TS and 21. Now it works perfectly again. And what's funny, if you look in internet, JPA, JSF, for instance, you will find a lot of tutorials. This one, for instance, is from Eclipse. And what you see is they just show you how to integrate JSF with JPA without EJBs. Usually EJBs are considered to be too complex, which is funny. But instead of using EJBs, they're doing the following. They are creating here entity manager factory for each call, and then the developer has to wrap each call, each interaction with the entity manager with own transactions. Right here you see is it fetches the transaction, begins, commits. Here is actually no rollback, which is unfortunate. There should be also a rollback in case the something goes wrong here. A little bit problematic, and just getting rid of EJBs would result right now in Java 6 with lots of complexity, because you will have to control the transactions by yourself. Yes, this is so far our small applications consisting of EJB, CDI, EJB, CDI, and backing bean. What you could also do, for instance, you can declare your methods as asynchronous. For instance, let's say this takes a long time, and this is an I/O operations which can take a bit longer. So we will have to simulate that with thread sleep, let's say 2 seconds. And just we'll try to recreate that. So TS22. As you see, it takes about 2 seconds, or I would say exactly 2 seconds, to store an entry. So, and to make it asynchronous, you will have to look in the spec for asynchronous, and you will probably find an annotations with the name asynchronous. And this annotation executes the method in a background thread, in a transaction, and the background thread is managed by the application server, so from usually in a thread pool, and this should solve the problem. So in, as you can see, Now we don't have to wait. The operation is performed in background. So a single annotation, no interface, and no interface. There is no interface between. Introduces asynchronous processing in Java 6. What you could also do, let's say we would like to measure the actual performance. So we would like to introduce a performance monitor class. It would be an interceptor, and the interceptor would just measure the performance of a method. It throws an exception. Proceed. And I would like to wrap that in try and finally block to measure the performance actually. It would be long start equals. And let's say ec get method plus executed in system current millis minus start. So just these are the milliseconds, and we are ready to go. An interceptor, there is an you need to implement a single method. The name doesn't matter, but the signature does. So it has to return object, expect invocation context, and throw an exception. And there is one annotation called around invoke. And I would like to use this guy here. Interceptors. And performance monitor. This is the guy. Yes. So 27. And you should be able to see here the performance are 2 seconds. As you saw, this is an asynchronous operation, takes exactly 2 seconds, but we can just try it here. For the index class, it could be significantly shorter. You see, this get session is executed in 0 milliseconds, and the which is quite fast, and the session store save took 2 seconds and 8 seconds and 8 milliseconds. So it is actually okay. What's also interesting in Java 6 is extremely easy to distribute events. So let's say I would like to notify someone per email that a favorite, for instance, was stored in the favorite application. So I would create a simple class called favorite listener, and this guy is interested in favorites on storing. And there is a new annotation called observes, and this annotation replaces actually the observer pattern from Java SE. I would like to observe the technical session, and this guy say thanks for notification plus TS, and yeah, this guy is ready to go. So it is a listener. It's somehow like local publish subscribe pattern. So you can just send and receive as many events as you like to. And what's only considered is the type of the event. The name doesn't matter, and the type is important. So I would do it in the actually it doesn't matter. We could for instance do it here right now, or by saving it. So what you can do is you can just inject the event of type technical session, listeners, and with simple add inject. So, and what you will see here is, I would like to do it afterwards, listeners fire session. So let's retry that. As you can see, thanks for notification was delivered immediately, and the index get session was still very fast, 0 milliseconds of course, and the method add took a bit longer. So what you saw right now, it is extremely easy to distribute events in Java 6, and this partially will replace JMS for local event delivery. To conclude my presentation, it is actually extremely easy to implement Java 6 applications. Deployment is extremely fast. All the tools like profiler, debuggers are available for you, and in my opinion, you should start with Java 6 first, and in case it's not enough, then look for the alternative, because Java 6 is extremely well documented and supported, and is also extremely popular. By the way, all events in the recent 2 years were completely sold out, all Java EE related events. On conferences, Java 1 sessions were repeated and workshops. So it is actually a very good sign. And what I also saw this year, first time ever, is that Java 6 catches some momentum in startups. So actually young companies, startups, at least here in Europe, are asking me, can you help us? We have some idea we would like to build it with Java EE. And yeah, some companies got a feedback that even it wouldn't be possible without Java 6 to implement such functionality in such a short amount of time. So thank you for watching this screencast, and see you in my weblog, Twitter, or one of my upcoming events and workshops, and enjoy Java 6 hacking. Thank you very much.